Welcome to Small A. I've been asked by two people for dimensions for this small little tool. So if you're new to the channel, this is a compound rest for my Unimat SL1000. The maker did not make any compound rests for these, so there's only one right now. And I hope more people make those. So let's try and help, and I'll tear it apart and put it back together. So I'll try to make some sort of a drawing, but basically it's fairly simple. These are 4mm by 4mm cutting tools, and you can just, let's get that one off, and let's take a look. Oh yeah, we need this one as well. Now what we're doing now is we're handling the stop. So there's a Teflon washer, that's my stop. I wanted a soft stop, so I made this washer. This is an M3 screw. It has been drilled and threaded, tapped by the edge. The lead screw here is a commercial 3D printer lead screw. So you can buy these because my Unimat doesn't have the thread engagement unit, so I can't make threads that long anyway. Alright, let's take it out. Now we've got it field stripped, let's discuss details. This is a lead screw for a 3D printer, and I chose this one because it's 6mm in diameter, which means I can run the whole length here and turn down this narrow section that this internal screw holds, which makes sure it sits and turns and does not move. So total length, give me a second there, of the lead screw is, there's a flat stop spot here. Lead screw total length is 88mm. I could have made it longer. On second thought, I think it should be shorter for more rigidity, but that's pretty good. This is just a handling knob. It's actually useless, quite useless. You don't need to make it. I made it from some stainless steel, and actually don't use it. There's a locking screw at the back here. So if you have a knurling attachment on your lathe, or you have a knurling tool, a knurled surface would be much better, because I really rarely use this one, just for finishing touches when you want this sort of soft movement. The knob here, the handle here, is 19mm, which is what I had, some aluminum. Internal cavity is 10mm deep, and we have a threaded section that holds an internal screw, and this holds basically the rod. So let's lock it back in place. As for the section itself, let's start with the base. These two sections are made from, well, everything's made from brass, but they're made from 20mm stock. They're held by these two locking screws. Yep, 4mm screws. And let's go for dimensions. So I had to compromise. I couldn't put the lead screw running through here, like in the middle. You have to do it to the side. So this is a 20 millimeter by 10 millimeter block. So 20 by 10. You can't put the hole in the middle because then your lead screw will be above your locking area, like so, and you won't be able to lock your compound rest to its position on the lathe. So you have to give it some room. So I moved it to the side. This is, you see there, we got 3 millimeters there, and it is 14 millimeters from the bottom, which means we have 4 millimeters of clearance. This is running through here, has 4 millimeters of clearance between the threaded rod and the bottom of the unit. So that's that. I'm gonna have to make several drawings. Let's put that back together. Two main challenges were basically the bed here, which we'll talk about in a second, and this unit. Okay, so let me lock that. Good. So the bed, I opted for a T-slot, so this just rides along in this. It didn't turn out symmetrical as I planned. The Unimat is not a really good mill. As a lathe, it's pretty decent for a tiny thing. As a mill, it's not. So again, this is the same block of 20 by 10 millimeters. So you can see it's 20 by 10, and this was supposed to be symmetrical. 13 millimeter width of the bottom section. I've got 3 millimeters here, so 7 millimeters were removed by milling. The hole here, which is for locking the screw, basically, you can see the screw here, it has been reduced to a minimum, basically speaking. Sits nice and not proud at all, and it's located where it will not interfere with the lead screw. So if I'm putting it back together for a second, and the lead screw, take the locking end off, goes right through the system. You can see that I have enough clearance for the head itself to fall through the head of the nut. So where do I position it? Well, it's got to be in the middle. So I put it in the middle lengthwise. So we have, and this is a 6 millimeter hole. Yes, it is. And it is 27 millimeters from the side, and 27 and a half. So if we take the other end, and we get 27 and a half millimeters from the other end. Total length is, and again, if I make it again, it'd be shorter, not longer. That's 61 millimeters. I aimed for 60, and I was very happy with 61. No special reason. But seriously, more than 2 inches and you get chatter. And I don't use most of the length of this thing. I mainly use just the end because of practicality reasons. Because if you're turning, for example, some material at an angle, this will be bulky against the chuck. So you just need the end. So you can make it 1 inch long. That's going to be probably good enough. 2 inches maximum, not more for this tiny little lathe. So 61 millimeters is way too much, trust me. This section, as we measured it, was 30 millimeters long. You don't need it that long. 1 inch would do just fine. You can countersink the screws into the metal. I opted to leave these because it sort of makes a funny face. Not real reason. Just was happy with those as they were. They didn't interfere with anything, so why bother? And I may do that one day. Right. So this is the base. This slides onto it and just moves fairly smoothly. I tried to be as accurate as possible. And on we go to the most interesting part. There we go. Okay, this actually came as a unit with the lead screw. It was round. You can see the hacksaw marks. I just cleaved half of it so it can fit nicely the whole setup, and used it as is. If I were to make that again, it would sit on the outside, not inside. 2 reasons. One, when I feed, I have to unscrew to move this setup out, not in. So this is kind of annoying. With the lathe, you usually thread clockwise to lead something out. Doesn't matter, nothing crucial. I usually just take the first stroke and say, aha, okay, I did it wrong. And that was it. I'm starting to cut. But basically speaking, if you can, put it over there. So we've got 2 and 4 lead screws, locking screws that are locking the cutting tools, basically speaking, these in their slot. Let's discuss that for a second. The screws are located 1.5 millimeter from the edge, spot on, and 3.5 millimeters from each edge on the right and left, as you can see. Yep. The threading goes all the way through because I wanted something that will be fairly solid. This is brass, it's not steel. So I opted for more threading. The cavity for the tool itself is just shy over 4 millimeters. It's 4.2 or 4.3. It is 4. Sorry, that's a lot more than I thought. It's 4.8. Yep, 4.8. And over here, 4.7 over here. So it's not too tough to put something in. You got enough clearance to play with it. Let's use this surface as a measurement surface, basically, a reference surface. So we are almost 11 millimeters, 10.7 millimeters above the top area here. Now this is not a crucial measurement. You just have to make sure it's not interfering with anything. And the only crucial thing here is actually the bottom surface over here. Why the bottom surface? Because you want the tip of your tool or your cutting tool, this thing, to be in the same height of the center of the chuck, the spindle, basically speaking. So this is crucial. So to make sure you're actually centered along with the work or with the center of the spindle, you have to make sure you're 12 millimeters above the carriage. How do you do that? Well, let's measure. 4.5 millimeters thickness plus 3.5 millimeters thickness over here, like this sections. So 3.5 plus 4.5, we have 8 millimeters. 8 millimeters plus 4 millimeters of tool are 12 millimeters total. So that's my math. That's how I established this. So this is your actual reference surface. This is what's touching your the basically your carriage, locking onto your carriage, and you have to be 12 millimeters. I mean the tip over here, 12 millimeters above the bed. The internal cavity is, let's see, of course centered. Actually lock these together and then drill the hole right through. And this is located dead nuts at the middle of the height of this section. So this is 13.5 millimeters tall, and we have 2.2 millimeter wall thickness here, 2 millimeters over here, just slipped a bit, and this is 10 millimeters in diameter, if I'm correct. See? Yep, 10 millimeters in diameter. And so it just houses this thing, basically speaking. And it's a snug fit. Holes over here are less critical, or basically after I established the position where this sits in, I just used the same holes it came with as guides and just drilled the holes there and tapped. The ways, well, as I said, this is an entire block of 20 by 10, which is what I had. So the T-slot here has to be 20 millimeters, and it is 20.1 millimeters wide, and it is located, the slot here is 3.3. I goofed up there, I think, because it was supposed to be 3.1 or 0.5 with very little bit of clearance, but it's 3 millimeters here on the dot, and it's 3.3 over here, which gives me a little bit of a wobble, but not too bad. Over here we have 3.2 millimeters. This entire block was cut from 20 by 20 millimeter piece of brass, and it is 41 and a half. You could do 40 millimeters long, and of course 20 by 20. I can show you that. So basically that's all there is to it. It's not, it's the milling of the slots were the toughest to do, but not that much. And I've got a full series of videos on that, so you can see that yourself. And basically speaking, that's all there is to it. Let me assemble that. Okay, so I really hope I hit each and every one of your requirements. Oh yeah, the slot may have missed one thing, which is the slot depth here, which is again not crucial, but that is 5 millimeters, 5.2 millimeters deep. And the idea is that you can go like that, a bit wonky. Now, given the option, I'd make that a bit deeper, because you sometimes need really steep, over exaggerated over here, but steep angles just to reach where you want to reach. So that's another option you might want to consider. And this is how the stop works. Basically, it doesn't allow it to move too much forward, and actually it's already located at the very edge. You can see that we're running out of track here, basically speaking. So I can make it shorter, and I think I will make it shorter one day. And we'll make it, more or less flush here. So not a big problem. And that's about it. Now let's try that, find that notebook page. Yeah, actually it's the first one. And a bit torn off. Okay, let's see if we got any dimensions there, because I had, well, that's the way I envisioned it, basically speaking. I thought of adding some markings, but I never got to that. So the design was for 60 by 10. And let's see what else I got for you guys. That's the TFM slug design. Well, apparently I had lots of designs, but I don't have this one. Alright, so I'm going to review my own video and trying to design something more solid. Actually, if I'm thinking about it for a second, I had a pack of sheets with the numbers and everything, and I think I just chucked them off when I was done. They were entirely from scratch. So, yeah, sorry about that. Alright, so thanks for watching. Hope you found it useful. Hope you can try and make your own. I'm going to... how do I give you the file? Well, if you email me, I'm going to email you the PDF file. It's going to be a PDF file. It's going to be super simple. And feel free to ask questions. Email me. I'll try and answer as fast as possible. If you get stuck, if you have better ideas how to make these, if you have suggestions for future makers, that's about it. So it's free, it's for you guys. Enjoy, make one. It's a wonderful tool. I'm really happy I made it, and go for it. Thanks for watching. Have a sweet day.